Hello everyone. So let's see how to solve today's question. So today's question is zero array transformation 1. Let's go through the question description. You are given an integer array nums of length n and the 2D array queries where queries I is like LI. For each queries I, select a subset of indices within the range LI in nums. Okay, so if you are given, let's suppose like 0 to 5, so you can select any subset of indices from it like 0, 3, 0, 1, 2, 1, 4, 2, 3. You can select any subset of indices in this range. Now decrement the values at the selected indices by 1. So whatever indices you select, you have to decrement the values at those indices by 1. A zero array is an array where all elements are equal to 0. So a zero array is defined as where all the array elements are 0. Return true if it's possible to transform nums into a zero array after processing all the queries sequentially, otherwise return false. So we need to perform this operation on the array and we need to return if we can make the zero array or not for this given nums array. Now last line is just a subset of an array is a selection of elements, possibly none of the array. So this is just what I told you. You can select any subset from it, like 0, 3, 0, 1, and you can select none. You can select none of the elements, so that is also a valid one. Now let's see some examples and let's try to understand the problem a bit more. So in this example, what you are given is this nums is given. The nums is 101. This three size array, and the queries is only one query is there, 0 to 2. So you can basically select any subset of indices from this 0 to 2 to decrement the values. So suppose if you select in this 0 and 2, because this 0 index and this second index is the place where the value is greater than 0. So we need to decrement it. We don't need to decrement this one, so we won't be selecting this. So we will be just selecting 0 and 2, and we will decrement this by 1 and we will get 0, 0, 0, and indeed we can make a zero array, so we will be returning a true in this case. Now let's see one more example. The second example, let's see. So in this, what we are given is we are given two queries. First one is 1 to 3, second is 0 to 2. So we can decrement any values in this 1 to 3. Now as all of them are greater than 0, so we will decrement all of them by 1. So what will the array become after that? The array will become like 4 to 1, 0. So this 3 will become 2, this 2 will become 1, and this 1 will become 0. So we have decremented the values at 1, 2, and 3 index. Now if suppose you also do this query, so 0 to 2, so we will decrement all of these values. So now after the query performed for the first one, the new array will be like this, and now we will again perform the 0 to 2 on this. So 0, 1, 2. So now these all values are greater than 0, so we will perform the decrement of operation on all the values. We will select all the indices. So after doing that also, the array will just become like 3100. This will be directed by 1, this will be directed by 1, this will be directed by 1. So since we cannot make this array as 0 for all the places, so we will be returning a false from over here. So I hope you have got the question idea what we need to do. So let's try to think of approach for solving this. So now, first approach which obviously comes to mind is just a brute force one. So what we can do, we can just iterate over all the indices given in this given for a query, and we will decrement the values at that position. So we will just iterate over this 1, 2, 3, then this 0 to 2. We will iterate over this 0, 1, 2. Okay, so we can iterate like this for each of the query, and we can just decrement the position. So in the worst case, what can happen is that in all the queries we might need to iterate over all the positions. Okay, so if you see the nums.length is given as 10 to the power 5. So for if and the queries of I is of length 2, and this LI RI can be till nums dot length. Okay. So now if you see for if for each of the query, if for each of the query I need to do n operations. So the queries can be how many? The queries are 10 to the power 5. So for this 10 to the power 5, if I need to iterate over all the 10 to the power 5 elements, so this will give me 10 to the power 10. So this this approach of n into n won't be accepted. So we need to do something better for it. So now if what we need to do in this is, suppose if somehow I can find for from how many queries I can deduct this value at each index. If I can find like how many queries are helping me to deduct that value. So for, let's see, in this case 1 2 3 and 0 1 2. So this 0th index is being deducted by only one. This one index is being directed by 2, this 2 index is being directed by 2, and this 3 index is being directed by only one of the query. So as this 3 is in this first one only, and this 0 is in this second one only, so these two are being only directed by 1, and these 1 and 2 are common in both of them. So we can direct these indices by 1 two times. So if I can generate this array somehow, if I can generate this array somehow, so then I can know for each position how many times I can deduct. So if that value is less than the value at that index, then I can just not simply make it 0. So suppose if I can deduct this value, if I can deduct this for only two times, then there's no way I can make it a 0. It has to be it has to be greater than or equals to the 4 or the nums of I, if I have to say. So it needs to be greater than equals to nums of I. So our task is to generate this, and this also, so in the question, as the constraint are a bit high and it's still 10 to the power 5, we need to find an approach of something of n or n log n. Okay, so we will be doing things in O of n in our approach so that it gets accepted. So now how will we generate that array of finding out like how many times I can deduct this value. So suppose if we were having five size array, and for this five size array I was having this queries. Okay, so 0 to 2, if I can deduct, I can just go to each of them, each of the place, and I can increment it by 1. Then for 1 to 3, if I have, then I can go to each of the place at 1 2 and 3, so I can increment the values by 1. And if for 2 to 4 I have, I can just go to every place and I can increment the values by 1 for that also. So now if I have to generate this, so this will also be having the same time complexity n into n, because for each of them I am just creating a new array, and for each of them I am iterating n times, so that won't help. So I need to generate this array, but I need to generate this in O of n. So for this we have a trick. Okay, so now I will let you know. So this trick is useful generally when we have to update by some plus x or minus x, like, so whenever we have to update some elements in a range only one time, then we can use this. Okay, so let's see that trick. Okay, and then we will know how to solve it. So if we see, we have suppose like these queries we have. For these queries, what will be my array? Let's think. First of all, what should be my output? What should be my output for this is that uh, the I will go to each of the uh, position. I will just increment by 1. I will just increment by 1. So if you see, if I will increment the values by 1, so I should get 2 3 3 3 3 2. Okay, so this should be my result. Okay, whatever is given in this, I have just incremented the values by that time. So 0 to 2 I have just incremented, 1 to 4 I have just incremented, 0 to 5 I have just incremented, and then 3 to 5 I have incremented, and I have just added the values. I have just added the values and I have placed it over here. So our output should be like this. So now how to do this is that what we will do at every starting position of this query, we will place a plus one. So if you see at this zero, I'll place a plus one, and at every plus one of the end. Okay, so at every plus one of the end, what I will do is I will place a minus one. So if you see, the end was 2 over here. Okay, so the end was 2 over here, so I'm placing a minus 1 over here. So if you see now, similarly, what I'll do for this 1 to 4, I'll place a plus 1 over here and a minus 1 at this 5, because plus 1 at this index plus 1, we have to place a minus 1. So similar thing I will do for this also, 0 to 5. So I will do a plus 1. So this plus 1 will become a plus 2, and then and at this 6 I'll place a minus 1. Similarly, I'll go to this 3. I'll go to this 3. I'll do a plus 1. I'll do a plus 1. So this minus 1 will now become a 0. And at 6, I'll do a minus 1. So this minus 1 will become a minus 2. So now, how is this helping me? So for each of the query, I just took O of one time. I just went to two of the indices, and I just place a plus one and minus one at them. Now, if you take a prefix sum, for these values, what you will get is the same array which we got if we iterated over all the indices for each of the query, and if we incremented it like that. So we are getting the same result. If you see this 2 3 3 3 3 2 is the same as below. Okay, so we are getting the same result. So this works. So what happens is that every time I need to increment a value in a range. So if you just see this, okay, if you just see what happens when I take a prefix sum. So when I take a prefix sum is that what I'm saying, from this 0 to this 2, I need to increment by 1. And so when I will be taking a prefix sum, so this value is a 1, I will be adding the previous value in it, so this will also become a 1. Then I'll be adding the previous value in it, this will also become a 1. Then for this value, I w- I will be adding the previous value also, so this will be becoming a 0. So you see the increment happened at only the places which were there in my query. Okay, so that's how it's helping us. So this plus one is just indicating from this I need to start the increment, and this minus one is telling us at what place we need to remove the effect of that increment. So we go back to the initial configuration again. So that's how it's helping us. So we will just do the same thing, and once we have this, the result is simple. At every position I'll check how many times I can decrease that value, and if I can decrease that value at least the number of time which is there at that nums of I, then I can make that 0. So okay, so now let's see this same approach in the code. So what I have done is I have just taken a number of updates array. This number of updates array is there, and I have just incremented the value at the starting position by plus 1 by just doing this plus plus. I have just decremented the value at nums of at query of 1 plus 1. As I told you earlier, we need to decrement the value at plus 1. So if this are 2, we need to place a minus 1 at this. Okay, at this 3. So I have done query 1 plus 1 and then a minus minus over there. So now once we have that, what I'll be doing is that I'll be just taking a prefix sum. I will be just adding the previous value in the in that in this number of updates. This number of updates will tell me how many times I can update a particular index. So if number of updates for any position is less than the nums of I, so if suppose I have a number like 4, and and the number of updates I can make on that is just two. Okay, so there is no way I can make that a zero. So I'll be just returning a false. And if the number of updates is greater than equals to the nums of height, then it's fine. So I will be just checking for each of the place. So this is the O of n loop. This is the O of n loop. And after that, if I'm able to make all of them zero, if there is no false condition in the array, I will be returning a true. Okay, so we have a O of n approach for this, and the time complexity is O of n only, and the space complexity is also O of n because we have taken this number of updates array. So yeah, that's about it. I hope I was able to make you understand the approach and the code also. So yeah, I hope you liked it. So see you in the next one. Thank you.